Yes, we can go ahead.
All right, thank you. Okay, so we made use of the OS library. The OS library, we were able to do a number of file system functions, like getting the current directory. And you can get the parent folder of any particular thing. So I'm going to, let us run through quickly again. Run that. So what we got, that's an error. So where is the error? OS is not defined, yes, because we didn't run the import. So run the import, get the current directory, get this. So it's telling us here the grandparent directory. Saying the grandparent is class test, which just shows this folder. Now to run along quickly, you can open a file, still with the file system, and we work with this special case of CSV file, because the CSV file was useful after all. So we work with our file system in order to write a file. And it was introduced that there are three modes. There are three modes of interacting with the file. So we call it input output. File IO, that's what we call it in general. So you can read the file. So we say it is open for reading or hard. So you can write into a file, we say it's open for writing. Abbreviated with W symbol. And the third is append. Append is A. So append is reading plus writing in effect. Because append is, first of all, read the initial thing that is contained in the file, and then you are now adding new thing. That's like an append. So an append does not overwrite an existing content. You just add to it. A writing will always clear up existing content. So we just run through our writing system here again, and we make use of this with open statement. We open A here means append. So in order to overwrite what was there, we just do, we start with W, run the W. Is that run that? No, W should be small letter. Should be small letter. What am I having? Okay, that's small letter. So we run this through. Okay. You know, we ran through this a multiple number of times. So we now use the append. Run. We run it like 5 times, I guess. So already we have some content in the file. So in the second part, we try to read out what we have in the file. And we use the open statement, but this time we are doing as read. And we call it file handle. The file handle can be F as well. We can call this F. So that's the F dot. So I just write it in full name to show that it's the handle generated for a file. It's like a pointer. So you can now say you call the file handle, and you can read the lines and it can produce an output. So we're going to run this and see what we have in the file. And by the time you look at it, this is the CSV file. This is an ordinary read. And you can see all the content that was generated. Now, here we introduce Panda. Panda is a data processing library in Python. Now, I'm going to compare very quickly reading this file traditionally with a file system. So here we use the file system to read the file, and you can see the output. Now, we're going to use the Pandas library. The Pandas library is very useful here because we have some predefined data formatting and data analytics. In order to do that, we're going to read the CSV into a Pandas data frame, unlike reading just into an ordinary file. So the syntax for that is to say df, you must have imported Pandas in your system. So Pandas is imported as PD. So we can call it and say pd.read_csv. Now, if you want to read into, if you want to populate record into a data frame, you can read from CSV. Another alternative is to read from Excel. You can read Excel if you have an Excel file. Now you can read SQL. You can do SQL from SQL. That is MySQL database, Oracle, Postgres, Redshift. You'll be coming across a number of databases in your data science career. So we can read. These are options. Then you can build the content of a data frame by converting a list into data frame. Now, we already have our CSV here. So note that this is just comments. It's just a comment for us there. So reading the data frame here is as simple as calling the Pandas library and call the read CSV function, then passing the name of the file. At times, let me run this and make a comment. You have that. I'm coming here. Now, at times, it will not be sufficient to just pass the ordinary name of the file. Let me tell you the reason why this is working. The reason why it is working is because this file, look at it. I'm scrolling up. This is our current directory. Now, if we create a file, it's going to drop in the current directory. So we created this file without specifying the absolute part of this file. We didn't specify the folder, we just create a file. Now, what the Python system will do is to create the file in the current directory. So this file will be created in the current directory. The current working directory. Similarly, we're now reading from the file. Here, we are reading from the file. It's still the same file. I'm picking something from the directory, similar to these Pandas. If you just pick the relative name of the file, and you are not specifying the absolute part, it will look for the current directory and read the file. So in situation where the file is not accessible from the current directory, you have to specify absolute path for that file name. While for this example, reading using the relative name of the file is useful. So I want to just introduce variable for the purpose of notes. Just a relative file name. Relative file name is equals to test1.csv. As opposed to relative. Now, if we are to deal with this as an absolute file name, in practice, the absolute file name will help you to wriggle out from a lot of errors and debugging when you are dealing with file system. So I just want to introduce this. We are not using the variable. I'm just taking it as a note. So we have the absolute file name. The absolute file name means you must specify the entire path. And look at it here. So you copy the path. So copy that. And I'm going to tell you one trick again. So paste here. So you can see the difference between the relative file name and the absolute file name. Now there's usually OS differences between Mac, Linux, and Windows because of this backslash and front slash. So you understand? So because of that discrepancy, at times you will have errors when you are using what belongs to Windows or the system that is well adopted in Linux. Mac and Linux, they use this / in the file system separator. The Windows uses backslash, and that and the backslash in Windows like this. We do this. You know, backslash means something else in Python. So what does it mean? Somebody? Can somebody contribute quickly? What does backslash mean? I'm just showing you. I will remove that changes now. So what does backslash mean?
I'm not sure at the top of my head right now, but maybe it's like to end the statement.
All right. So maybe you are there. Okay, if I do this, what does it mean? Okay, let me just move on. Look at this. What does this mean? Can you see what I selected there after this 1980-122 date? Can you see it?
Yes.
What is that?
Two separate.
That's separate line.
Yes.
So the backslash n is new line. So backslash n is new line. Then we have a number of this backslash. You have backslash t, that is space tab. And anything, there are a number of them. They are called escape characters. The escape characters is backslash followed by something. So the backslash is an escape character in general. So then you have the escape sequence, one character followed by the backslash, the escape sequence. So backslash will always mean something else. So when you are dealing with over here now, so when you are dealing with Windows file system and you have backslash, the trick is to use double slash. That is escape. You understand? So if you use this method and you use escape, what it does is the interpreter will evaluate it as single escape. So you can see this in some of the codes when you are reviewing the code. Now, the system will be confused if we put a single backslash. Now, there's one more method of dealing with this, is by putting R. You can put R in front of the R inverted comma. Look at it very well. R inverted comma, then the name of the file. You also use that to escape the file system separator. Most time you don't have issues with Linux and Mac, but on Windows system, that backslash will give you issue and you must know how to handle it. Very quickly, look at our new data frame. Our new data frame is here, and all records from that is coming out. So we say DF, that's the entire set. So that takes us further. When you are analyzing the data can consist of 1 million records, and you may not be able to verify what's in there. So you use this certain function. So we have the add function. Add by default we give 5. So now you can say add, you can pass in a parameter. If you say add of 3, you get the first 3 records coming out from the data frame. Then similarly, you have tail. Now, if the function is not specified, it does 5. The default is 5. So from tail end, from the edge, then you can know the shape of this data set. The shape is rows, how many rows, and column. And as you can see, we have 5 columns, and it's telling us that we have 23 rows. Now, further, we also look at this transposing, like in the transpose of a matrix or Excel pivot. You can get the transpose of a data set. So let us do something. Let's say, let's do transpose of this guy, this tail. Instead of transposing everything, let's do the transpose of the tail and df dot tail. So it's only now the df dot tail returns another data frame. So the output of that function is another data frame. So df dot tail is a data frame on its own. So then we now pull the transpose. And we'll say run. You can see. Now we have the heading as becomes the row labels. Then the row labels has become the heading. Now this can prove very powerful when you are doing data analytics. Now you can list all columns very easily. Just say df.columns. So it shows all the columns. That's an attribute of, and we just did this again, checking first 3. Now you can pull up a specific column, like date of birth. So we say df of date of birth, and we see the column output. Now, this tells us something, and it's one of the fundamentals in data processing. When you inspect, you can see that this data is dirty. We say date of birth. Date of birth should be date. But here we have string. Now, we inserted this heading in the process of building that data. But this heading is supposed not to be there. This is not a real data. It's not a real data. It's not a real data. So we have to do a little cleanup. The system interpreter is even confused. Instead of having date time, Yeah, it does not know. It says it's an object because we are mixing string, we are mixing date. So if we say what type, we use the df types to check various data type on the object. And it's telling us ID is an object, first name is an object, last name is an object. A lot of confusion there. So we are doing a quick cleanup of data here. And this is our first data cleanup exercise. Now, in order to clean up, you use a filter. We use a filter. So one method of filtering is to pass in a condition into the data frame. So the condition here is that the date of birth must not be equal to DOB in string, the string value. So look at this string value. We'll say date DF. If we say it's equals to DOB, see what we're going to get. Let us run that. It means, look at it. We just have all the DOB. However, these are the records that we don't have. So we're going to invert this condition and put the not equal to. Remember your logic. So bring out all the records when the column date of birth is not equal to this string because we don't want it. So if we run that again, what do we have here? There's an error. Oh, wow. Oh, we have an error there. It's not equal to. Or I know what happened. Something is wrong. Because this DF object, you have to be careful. The DF object is already altered. It's altered. And by the time we run the first one, it's altered. Now, if you get what I mean by that, you can just comment. And if you don't understand, I can elaborate. Is our DF object is messed up. So I'm just going to quickly load again. So I'm scrolling up to load where we loaded the CSV. So we need a fresh DF. Now, from here, we just load. So we have our fresh DF. So I'm going back to that place. So coming to okay, so this filter, run it now. So I have it intact. Now, here's the trick. Each time you are performing an operation on a data frame, it is better to name the result as another variable. Who knows? You might need the original data frame from time to time. I'm not going to implement that here. So, but let's take note of that. It's better to assign it to another variable because the data frame is a mutable object. So we have dictionaries, we have series in Python, we have tuple. Tuple is immutable. That is, you cannot destroy the content. Once it is created in the life cycle of that program, it doesn't change. We say it's immutable. So we have objects that are immutable, they don't change. This data frame belongs to object that is mutable. You can overwrite it. You can change the content. So you'll be very careful while reassigning the name using the name of that original object. So we move forward. We can see now that that column is gone. It's gone. The dirty data is gone. So the next thing we want to do is let's do something again. Yeah. I want to introduce this. The other time we try to check the value of the column. So df.types. Let us pull this again and see if anything has changed. So I'm going to put the df dot type again. If we run that, now it's still telling us that the DOB is object. Still confusing. Why? Because this date is in fact a string. You could not see it as a date type explicitly. So implicitly rather. So we have to explicitly convert that column to a data. So we convert that date string to date type. So in order to do that, we just you can pick a particular column. So a particular column here is selected from the data frame. We'll say it's equals to, we now call the PD. This pandas as a conversion to date time function. So the function is PD to date time. So what are we putting in? The input is the date of birth. I will supply the formatting string. What does the formatting string tell us? Year, month, day. So we are telling the interpreter that you look first for the year, look for the month, look for the day, then you convert. So let's run that. So we have we have a new object here, but let's do something. We look at df types again. That's the third time we're checking it. So df type, where are they? Now look at df types here now. It's not telling us this guy is a date type. If we scroll up to the previous df type, it was telling us it's an object. And because of this conversion that we did on that DOB column, we now have this guy becomes date type. The advantage of having proper object type is we can perform inherent operations on data that cannot perform on an object. For instance, from the date time, we can extract year. To do that on a string, you have to go through a lot of computational string manipulation, cutting the string, joining it together. But with the datetime object, you can just pull up year. You can pull up the year. So pull up the year, create an extra column called YOB. Now, if you run that, you see the output. A new column has been created, and you can see the YOB is derived from the DOB. And you just have the year. Similarly, we can pull up the month, and we can pull month day. So there's something in accounting that they call period. The period is the year and the month. So we can pull just the period, year and month. Can work with that. So here we're just listing out years. So this is just a set now, and this return a set of years involved in this data set. Now, we want to fetch out a particular data frame where the year, we already said here, we define here and say X is this entire YOB. We're not saying X, which is that DF of YOB, is equals to 1982. So we want to fetch the record whose year is 1982. Now, if we run that, you see all the 1982 will come out. Now we can invert this condition and say not 1982 using our logic. So if you run this, you discover that other guys will come out except 1982. Quite interesting. So quite interesting. Now, the next thing we are dealing with is type conversion or cast. Type conversion. what are we doing? We'll pick a particular column called X. You know our X that has been assigned there. We already say our X is a year of birth, and we are now converting it to an integer. So convert it to an integer. Look at it here. It's an int after this conversion. However, before then, look at it here, it's an object. The YOB is an object because it's a string that looks like an integer. So here, explicitly, we have converted it to an integer using this function. So converting it to an integer means you can do things like enumerations and series on that column. So it's telling you it's converted. And in this comparison, we are using string here. So this time around, we can use, we don't need to quote it again. It's not a string. Here is an integer. It's an integer. The integer type is powerful. You can do things with it, such as a range of values that you cannot do with string. So that is that. Now you can build data frame by another method. What we did there was to read from a file. We read from a file. Here I want to build data frame from raw data. You understand? So in order to do that, it means you have some data. You understand? For the fact that you have data, you can build it into a data frame. You understand? Here we have a list, 3 different lists. You remember we have the data types that we have in Python. We have the elementary data types. We have the integer, the string, the float. We have the byte. Then we now have the complex data type. We have list, we have tuple, we have dictionary, the dictionary object. Now, a tuple is close to a list. The difference is that a tuple is immutable and it uses instead of square bracket, a tuple will use a curved bracket. So if I write something like this, and I say a tuple is equals to, it will be in. Now, whatever you put here as a set, you can't change it. That's a tuple. So, but we're not using tuple. Just take note of that. It's saying here we have list, 3 different lists. The 3 different lists can be converted into a data frame. So we're building cast data frame. Let us start. We have a list of names. Names, United States, Australia, Japan. So that should be like country of manufacturing. Then we have drive, the drive side here. So the drive side we have here is either we're using a Boolean. So are they using right-hand drive? So called DR. So true, false, 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 true, true, true. That is against each of the country. Then we have CPC, was that? That's
the cost per capita.
Yes, how many cars per capita in the population? That's the ratio of cars to population. So we have this thirdly. So we are combining the 3 lists together. The first thing we do is to turn it into a data set. It's a dictionary. You know, a dictionary can contain list. So we'll see what we did here now. So now say this data set is label values, label values, label values. You know, that's how we build dictionary. A dictionary is a key value pair. A dictionary is a key value pair. So we have country names, drives right, there, cost per capita, then the list. However, this data set, this dictionary, a dictionary can be very complex. Instead of having ordinary value, it's having a list of values as the value for this key. Similarly, this guy is having a list of values as value for this key. This guy too is having a list of values. So having built that data set, all you need to do is to call the Pandas data frame and pass in the data set. What you have is a Pandas set. Now let's just run this and see what we have inside. Like this, we print the data set and eventually we print the data frame. You now see which one is easier to work with. Now look at the data set. Country label. The value, the value is a list of values itself. There you see, drives right flag. And then you have the list of values. Again. Then you have cost per capita, you have the list of value. If you look at it very well, if to visual inspection, this is not very, doesn't make much meaning. Look at the Pandas data frame equivalent compared to this dictionary. You can see the data is well organized in a tabular form like SQL. Oh, the country, oh, does it drive right? Ah, true, US is true. Then per capita, you can see how it is well arranged. Well arranged. So that's very powerful use of Pandas data frame. Excuse me. All right. So we have that. Now here we are building something else again. We have a row label. Now we can specify row label. What is row label? Row label is this 0, 1, 2, 3, 4, 5. In general, the rows are labeled serially. But then you can specify. You can specify another enumeration for row label. So we did that by passing another list. And we call it row label. And instead of using just 1, 2, 3, we just use code, like country code. So we created a row label of country code. So we now specify and say the index is our row label. So if we do that and print again, oh, you see that your 1, 2, 3, 4, 5, 6 is being renamed here. Like we gave it a country code. So still further analytics on that, we have columns. You can rename these columns. The columns, the first column is country. Maybe you want to write it better and call it country name. Drives right. You just want to do a title case, cost per capita. Instead of the underscore, you want a proper label. So if you do that, the columns can be changed. You can see it there. So we just change the label, nothing more. Why do we do this? Eventually, data analytic output becomes business reports. So, and when the business people are reading report, they want something presentable. They don't want your codes. Nowadays, we can just put a number of abbreviations and symbols to write our code. By the time you complete your analysis, you will want to present it in an executive report like this. So you want a proper label. And that's the essence of being able to name the column. So still further, we want to build another data frame like this using broadcasting data. So we have a planet, arts, and we have country names. We also have a dictionary constructed from planet and country names. So look at this dictionary now. The first label, we know a dictionary is key and values, or label and values. So we have country and the values, which is here. Then we have planet and the values. In any way, we only have one. That relates to civilization. So that's why we have arts. Now, pass this data dictionary, pass it into the data frame function, and you have something else. Just run it. So, yeah, it's obvious. Oh, the countries listed, they are in that. There's no one on Mars. You understand? So, there's no one on Mars. Next, we'll come back to our cast data frame here. The label, I think this is just a repetition of what we have from there. We specify row label again, and we have our stuff. We have the cast printed and called here as a function. Yeah, over to slicing. The essence of slicing is taking part of a particular data. You don't want all the column. So slice like you use knife. Just cut the country or cut the country name. And our new dictionary for cars is this, not that it's this. So in order to, what we did here is, first of all, rename, print out country columns. Print out country columns. I just want to edit the label, the comment. Editing this comment. Before then, the first thing we did here is to rename the use proper column name, or a more descriptive column name. So we did that. Now we slice out country and just right flag. Then we print out the result of country, class of country. So let's just print one of them, slicing those two columns. Run it. So you see that that's a slice. So we have a slice of that data. You can slice anything. So we just want to list the country. You slice out the country. And something is wrong here. We have an error. Why do we have an error? We have an error because we have renamed this country as country name. So the object does not have ordinary country again. It has country name as label. So once you change the label, you have to be consistent. So we're calling the country name. So you see, we're fine. And this one will be an error as well. There will be an error because the label have changed. So here, let us quickly modify the label. So the first column is country name. Country name. And drives right is a title word, title phrase. Drives right. So if you put this, you have your result. That's that. So what again now? We now do filters. Filters. First 3 cars, and then 4th, 5th, and 6th. So let me use the print function to wrap this so that we can see the two. Print of text. Print 1 to 4. No, in natural sense, 1 to 4, that range is first 3. And then you have 3 to 6 here. So run the 2 and let us compare. You have Australia, Japan. Now we have this. 1, 2, 3. 1 to 4 will give you 1, 2, 3. The last one will not be inclusive. Then look at 3 to 6. 3. India is 3. So why is it 3? Because it starts reading from 0. 0, 1, 2, 3. So India is 3 now. So if I want the very first guy, I'm going to put 0 here. 0. Bam. So look at it now. I have it from US. So first 4 observations there. That's it. So hope it is clear. Hope it is clear.
Yes, sir.
Okay. Now, if you want to filter as well, we have the iLock functions. And we have the lock function, LOC. We have the LOC and we have the iLOC function. We're going to demonstrate that now. What is the difference between iLOC and the LOC function? Can someone help us with that quickly? Yeah, Mr. Olu, what's the difference? I want all of you to contribute. Mr. Olu, what's the difference between the iLOC and the LOC function? Is Mr. Olu there?
Yes, I'm here. I'm trying to think.
Yeah, just attempt it. Attempt it.
I'm not sure right now, sir. I'm sorry.
All right. Mr. Derry?
Yes, sir. Yeah, I'm not sure, sir.
Ms. Funke? Are you there, Ms. Funke? Okay. I wish you can hear me. Okay, this is the difference. The two are filtering out specific record rows. So if we use the iLOC, Mr. Francis, you want to attempt? Okay, I thought you wanted to talk.
I think probably should count, right?
Come again?
I think it's for to count, right?
No, it's for retrieving a specific record. The two of them
Okay.
retrieve specific record. The difference is that this guy, ILOC, uses row number. The LOC uses row label. Row number, row label. Now, if we want to use the label, you use LOC. If you want to use the row number, you use ILOC. Now, good thing is that the ILOC is more flexible because you can say start from the back, start from the front. But the LOC, you must use specific label name. That's the difference between the two. That's the difference. The ILOC, you can be more flexible with the row number. So ILOC, you can, let me run something like this. See what we have there. You can say 01 and 02. You can see. So the two of them will give you a sub of the data frame record. NumPy. We're going to have a short break, and then we hand over to Mr. Dozier. NumPy is another library similar to Panda. It's an external library. This is for mathematical computation. So in this example, we have a list of integers. Now, NumPy, you can have an array of integers. So you do a lot of things from this NumPy set. You can create an array from a list. So just call np dot array of passing your list. Passing your list, yeah. So, and you specify the dimension. An array could be multi-dimensional array, 2 by 3, 3 by 3. Now you are specifying here that you have a 2-dimensional array. So the next thing is the list to run your array. So we have a 2-dimensional array created here. Now let me turn this to a 3-dimensional array, and you see what will happen. So I want you to observe here. Run that. Now you have 3 square brackets. It's now 3-dimensional, and so on and so forth. So the date function, we use the date object and function. So we import date time. The date time object, the data module or the library, there's a particular date object inside it. So from date time, you import date. Now, somebody should tell me what's the difference between this type of import using from and this type of import without from. Who could tell me the difference? Okay, we'll move quickly because of our time. If you import like this, you are importing everything from that library. If you use from, you are importing a specific object from that library. So we're importing date. So we can now, one of the things we can do, date. That date object itself has a lot of function. You can get to this date there. D is today. You can extract with day, and so on and so forth. Let's run that. So you can pass date string. Look at how date string is passed there. Is that date 1? That's a string. Date 2, that's another date string. These are ordinary string. You cannot perform arithmetic date operations. So you must first of all convert to real data. So the function for that is to call the date time object. Datetime dot strip time. Just strip time again. Stripping the time. Pass Y month day D1. So D1 has become date object, similar to D2. Now you can just do a date difference. Very simple. And you can say you want it in number of days. Very interesting. So again, NumPy. We demonstrated another important things in NumPy, which is doing random number. So we can do a random number. And look at what we did here is to generate a random number of range 1 to 11. So rand, you can have a random number and you can have a random integer. So you see the specification. So we can stop here so that we move to data processing after our break. So if you have any question, you can ask for 2 minutes so that we take our break. Does anybody have any question here? All right, let's take our break. We'll be back in 10 minutes.
Oh, sorry. Okay, sorry. So so this document is more like we're going to use Python to read this document. So you see the name of the file is marketing analysis. Okay. So this is just the original file within the whole system. So I'll close this page and I'll also minimize this folder. You'll see that this is actually the folder where this file is. Okay. And this is the same file I just opened up. You can see the name of the file. This is the name of the file. And let me open this folder again. You would see something. I would say, let's see, show part name. I want to show you. This is not, okay, get info. If you say get info, you would see this part. See this part, required lessons, Python 2022. Okay, downloads, class, Python, required lessons. Okay, you can see the path where the data, the location of this data. Okay, so we need to get this data from using Python, navigate to this environment and pick that file up. So this is just where we are. November, December, Python required lessons. Users, hopped on, downloads. The same way, if you run this through your system as well, it will tell you the whole path where your file is. And it will go in there and it will read this. Okay, so it did, and it pulled up this, and we just follow through with what we need to do. We want to do some data manipulations and all that. Okay, Mr. Diozi, are you there?
Yes.
Okay, go ahead. Yeah, that's the file. The file is within that folder space, and he's using Python to read that file. He's bringing it into the whole programming paradigm, and we can see what the data looks using Python. Then we're going to basically do some basic stuff, fixing the data, drop some columns. Then you see how we run charts in Python. This is more like data processing. Okay, feel free to ask questions. All right, DOZ, take over.
Okay, thank you. So after looking through this, then we need to fix some rows and columns. So with this, we decided to skip 2 rows in our data frame. Why do we do that? Because of, if you look at this, this is not consistent with what we need here. So we are going to use here as our column names, which is what we did. Yeah, so we moved our column to this, to the second row. And that's what happened here. Because all what comes after that are the figures and data that we need to process our data. Hence, we pass this skip rows to equals to in this parameter to this when we read our CSV here. Okay, then looking at the data again, what do we need to do? We can say that we have a column named job edu. So what can we do with this? You see, this job edu contains 2 pieces of information, and we can separate them into job and education. So this is how we do it. So we take here the job edu column. Then what we are doing here, we are adding a new column to our data frame. Our data frame is called data, remember from up here. So we are adding a new column, job column, equals to whatever the output of this will be the new column. But this here is defining that new column for us. So we take the job edu column, then apply. Do this method here is called apply. This is a method that takes a function and then does if you remember what a function is, a function is just a piece of a block of code, but this is called a lambda function that is just a shorter form of writing a function. So it takes a function and then splits it. What it's doing here is splitting. If you look at this our column here, it contains 2 comma separated values. So like on this first column now, we have management and then separated management and tertiary, separated by a comma, technician and secondary, separated by a comma, just like that, and so forth. So what we are doing here is we are splitting it into and taking the first item. That's what this function does. This lambda function. This particular function, we can write it as something like this. Say, let's call it there because get, since it is the job we are trying to get, we can say job. And then what are we passing? Let's call this X. Then return. X dot leads. Then we're getting the first when we split it. Then we can take, if you take this and put it here, it should give us the same outcome. Let's see. Okay, so it means it works. So I can do the same thing for get. Where is it? Education. So take the second. So what this one does is it takes this data, separates it by comma into a list, and takes the second one to get the education. Then we can take this function and put it here. It's going to do the same thing. I'm just trying to show us how the lambda function can be simplified. Lambda is a bit more advanced, but this is a function and we pass it into this apply. Apply takes this function and applies it on each item. So applies it on each row, each item on that column that we're trying to work on. Like now we're trying to, from this job edu column, we're trying to create the education column. And also from the job edu column, we're trying to create the job column. So this apply takes this function and applies it on each of this, and then gives us this column. I hope you understand. Then what we now do here is to now, after generating these columns, then we'll now drop data.drop edu. This tells us to drop the job edu column. Since we have separated it, we no longer need it. So dropping it means that it will remove it from this data. That's why it's no longer. I know if I run this now, I'll get an error because it has already been removed. So let me generate this back. Run this and then run this again. So yeah, we don't have the job edu column, but at the end here, which is not showing, I don't know how to expand this more, but towards the end, we should have So that's that. So here now, we want to see the number of missing values we have. We can see data dot is null then sum. So what this does is it counts the null value on each column. That is the columns that have no, how many of the data is null. Like, let's say, where we have null, this means that usually we'll see none or it's blank. So for example, in this age column here, it means that we have 20 null values. And here is salary, balance, and the rest up till day. There are no null values there. We have 50 in months. And then we have 30 in response. So there are 30 rows that did not have any response. That's what it means. That's if you want to get this information from the data that we have. Then dropping the records with age missing. So this is an example of, this is how we filter data in, this is how we filter data, the data from. For example, we want to remove all the rows that do not have, that have their data, that have their age as null. So we want to remove all those. So we want to say, what this says here is, now, first of all, if you want to filter in Pandas, this is an example of how we do it. You can see our data, or let's call it new data. Equals to the original data. Then we put our square brackets in front. Then we can see all the ones that have that do not have an age, all the rows that don't have age. So that is to say data that's age column, our column name, the column we're interested in, then is null. It's null, just check if it's, so let's see, new data. Let's run this. Right. So this is what I was trying to see. So wherever age is null, those are the rows that will show up here for us. Wherever age is null, it means that there is no value for age. You can do the same for, like, we have for response also. And if you say change this age to response, and let's see what the output will be. So we also filtered it. And response is You can't see, but it should be somewhere at the edge. So if you want to, okay, we want to say, for example, that for where contact is unknown, how do we do that? We can say data dot contacts, that's our column name, is equals to unknown. Yeah, so we get all the rows where contact is equals to unknown. So what if you now say, okay, it is not equals to unknown? One way of doing that is this is not equals to. So you can look at our contacts. It has cellular and some other values of telephone. Another way of saying not equals to is I think if we do this should work. Okay, yes. So whatever is within here, whatever our value, the truth value or the outcome of this will negate it. Just like this example that was earlier here now. If I say, when we said we wanted to get the values of the rows where the age is null, data dot age dot is null. This will give us all the rows where age is null. Then when we now put this sign in front of it, it gives us where the age is not null. That is where it is not null. Then gives us what we can work with. So this is it. So we can say that this what is, I can't remember the name of this sign. But wherever we put this sign within this, in this our filtration that we're doing, it gives us the opposites of whatever we put in there. Okay. So let's all this data set to reassign and remove all where data is none. So we have removed all our data, remove all the rows where data is null. And then if we print it out here now, you see that and try to check if the sum of the null values or the number of null values, we see that age is now 0. But before here it was 20. But reassigning it like we did here has eliminated those no values for age. Okay. So what I want to do next is, first of all, we get the mode. So a way of getting, we can do some, get basic statistics of data with Pandas. So we can see so what we are trying to do here is to we want to fill up the months with the most common value, like the months that are missing values. We want to fill it up with the most common one, and to get the most common value for the month, we can just get the month by getting the mode of that on that month. And when we do that, we get it to be May 2017. So that is what we did here. Using 0 gives us the first item. That's the way we access it here. And then here we replace it. So when we fill NA is a method used to fill all the non-values, that's the null values. Those are the missing and empty or blank spaces within that particular column. So what we are trying to fill it up with the mode here, which we got here, and we fill it up. Then in place true means that you don't have to reassign it when we run this particular line. You don't have to reassign it, like say data equals data. We don't have to do that here, as long as we put in place true here. But if we didn't do that, we'll have to we would have to reassign it. If not, we'll just lose those values or whatever we did on this line. Then after doing that, we now check how many null values is in this column by doing data.month is null. Then the sum of the null values. This sum simply sums the number of null values we have, and comes out to be 0. So then we check missing values again, and we found out that our data frame is now has no null values. So what we now want to do, we want to visualize our data. Then to visualize data with pandas. Initially, we did an import at the top here called this import here. Matplotlib is a library that helps with visualization of data. So with this, we can plot graphs of different kind and charts to see what is going on within our data. So for example, to do a bar chart of a particular column, you can see, okay, let's do that for age. You can say data dot age dot so we've plotted a histogram of the age. You can also plot a bar chart. It's still running. So write that is one. This is another way of so we can also plot a bar chart, but this is taking a lot of time because of the number of
It will take a lot. Yeah, it will take a lot of time because of the rotation and the X and Y axis. You probably want to specify them, but it's going to take a long time. Can you push to the other one? We can circle back to this when we do a rerun. Yeah, you need to specify the X, the rotation, and all those stuff.
Okay, so do a pie chart. For example, we took the education and run a value count. This value counts method. So this is the, like, we get our data frame, the education column, and this is a value count method. What this method is, it counts the values of the number of each unique values. That is all. That is what it will return. Let's see an example of that. Okay. Understand what is happening here. So yeah. So,
One second. Let me see that bar. Let me see that bar. 1 second. That should take care of that one. Okay, there's a keyboard interrupt. So you're fine. Yeah, let's leave that. The rotation 0 is without specifying the X and Y axis, but we'll leave the rotation at 0. So it picks up everything. So yeah, you can go ahead to this one.
okay. So this gives us the count of all the values. That means we have 2,300, sorry, 3,000 plus secondary values, and tertiary is about 13,000. So that's just what it does. Returns that's what the value counts returns for us. So then if we now decide to plot a pie chart of these values, now doing a plot of this, it's just do the normal divide them into sectors or circles in 360. I think when we include normalize, it's how will I put it? Probability does a probability distribution of it, of the values. So just like that, we have several kinds of charts that can be plotted depending on what we want to see from our data. Like doing a scatter plot of balance and salary variable data. This is how we do it. We take our plots PLT. We've imported this at the top. As macro library imported this at the top, then scatter. So this takes the salary column and then the data balance column. Then we show this is what the output will be. We can specify the same thing here. This is another way of doing it. This one is for data of age and balance. This is for salary and balance. This is another way of plotting the scatter plots. These are just different ways of doing the same thing. And correlation, also show the correlation. And then show it on a heat map. SNS is another library for heat mapping. So that takes the data frame of values that we want to show. And that what we want to show is the age, salary, and balance. We want to show the correlation between them. We take them and pass them into this SNS.heapmap. This is just another library which we imported at the top. And then show it. This is what the correlation looks like. So removing duplicates. Depending on how duplicates appear or where we want to remove duplicates from. For example, the easiest way of removing duplicates is removing duplicate columns. Sorry, duplicate rows. We can just say drop duplicates. But this example shows us how to remove column duplicates. So this is our data frame. Let me print what it looks like. And this is our data frame. So in order to remove column duplicates, that's columns that have the same values. For example, look at this column. Yeah. Column number 4 and number 5 and number 3. Those are duplicates, and 1 and 2 are duplicates. If we do drop duplicates on this, if we drop duplicates on this, it will not give us the desired results because they are in the column. So what we now do is we transpose the data. Transposing simply means we'll make the rows column and the columns row, which is what we did here. After transposing the data here, then this is what we'll have. The columns will become rows and the rows will become column. Then we can decide to give it the column names and then drop duplicates. Then when we drop the duplicate, it's easier because since they are now rows, it will be easier to remove. Then we can now transpose it back and return to its original form. That's how to drop column duplicates. Are there any questions?
Guys, any questions?
No.
Go ahead, I'm listening. So did you get a concept about the transpose or the charts? Or is something you want us to go over again?